we'll be solving the partial differential equation for the heated wire. So, given here, all we have to do is solve for an, which is just the Fourier series, cosine Fourier series. That's going to be 2 over L integral. Actually, we see here that ux0 equals x squared. Because of that, we know that t is equal to 0, so we can sub it in to this equation here. When doing that, this exponential function just becomes 1. So we can rewrite this as 2L sum a to the n cosine n pi over Lx. This is the same thing as this Fourier cosine series. Now we see here, to solve for that, we're going to say 2 over L, 0 to L, f of x we know is x squared, and then cosine n pi over Lx. Doing integrating this, we get cosine n pi over Lx, L sine n pi over Lx over n pi, and then negative L squared cosine n pi over Lx over n pi squared. And minus, we see x squared times L sine of n pi over Lx for n pi. These two negatives cancel out, plus 2x L squared cosine n pi x over L over n pi squared. This is going to be evaluated from 0 to L. Plugging in L for x squared, we get L cubed. These cancel out, so we get sine n pi, which is just 0. So that's 0 plus 2 L squared cosine n pi over n pi squared. Evaluating the second term, we see sine of 0 is 0 again, minus 2 times 0 sets this whole thing to 0. This is the only term we have to worry about. 2L cubed. Cosine n pi is the same thing as negative 1 to the n over n pi squared, multiplied by 2 over L. In the equation, they give 2 over L is already factored out, so the answer is just this, 2 times negative 1 to the n times L cubed over n pi squared. Alright, see ya.